Good morning, everybody. Thank you all for getting up here very early on the very last day of the conference for the exciting topic of billing. I'm glad that you all realize how important it is to actually understand what your business is, what it costs your business to run your software. Lots of people don't understand how important this topic is. Usually they think it's really boring, so I'm glad that you actually understand. My name's Evan Jones. I'm a software engineer at Bluecore, and we're going to talk today about going beyond your bill and getting more detail on cost. So first, we're going to talk a little bit about Bluecore's cost challenges and how I got involved in this. We're then going to talk about Google's existing cost management tools, what they give you out of the box. We're then going to talk about how you can create some of your own data sources when you need more detail on what things are costing you. And then finally, we're going to talk a little bit about some of the lessons that we've learned at Bluecore about this, and we're going to have plenty of time for Q&A because I tend to talk way too quickly. All right, so first, the reason I got involved in this is I started getting all these questions like, hey, why is our bill so high? Why did February cost us $123,000? Or, hey, why did our bill go up? Why does February cost $23,000 more than what January did? Or, what happened on this day? What happened on October 25th to cause our cost to be really high? Just a quick show of hands. Has anybody here had to answer questions like that for your business? All right, great. The rest of you, don't worry. Someone in your company will eventually figure out that you do, in fact, know how to answer these questions because every single organization needs to know the answer to these sorts of questions. Great. So why did we get here? So Bluecore, we are a 6-year-old startup. We do intelligent e-commerce marketing. We've been around for 6 years, based in New York. We now have about 180 employees. Our customers are hundreds of large retailers. So we are a software as a service application. And we sell to customers like Sephora, Express, Tommy Hilfiger, and other brands that I'm sure you would recognize. The company started with the intention of saying that email marketing for e-commerce isn't really being done correctly. The traditional approach is a retailer just sends the same content to every single customer that's ever shopped on their website. And Bluecore started with the intention of we should customize that and provide people information that's actually relevant to them in this email. So as an example of what that looks like, here's an email that we send for Timberland. It says, other popular purchases, and has 3 suggested products at the bottom. The point of this is a message that the marketer at Timberland has configured to send to their customers after they've completed a purchase. And then these products that are shown at the bottom come from our recommendation algorithms. And so these have been customized for the recipient of this email. Maybe it's based on the product that they already purchased or some of the other shopping history that they may have with this retailer. So these types of personalized messages are more effective, but there is a disadvantage. And the disadvantage is this is what our Google Cloud cost bill looks like. In all of the slides in this presentation, I've had to remove the actual dollar values in the y-axis here, so you'll have to apologize. But this is, in fact, our real Google Cloud bill. This is our top-level bill, daily cost starting in January 1st, 2017, through until February of 2019. This is as much data as the built-in Google Cloud Billing Console would give us. Now, because of some of these spikes and variations, it may not be extremely obvious, but this is actually a 3x increase over 2 years. So this is 75% annual growth. Now, for me, this is a great problem to have as an engineer. I love this because this means we've got to go now and figure out how to optimize this and solve this. It also means that our business is growing. So this is actually a really good problem to have, but we do want to make sure that our growth is in line with our business, or ideally actually grows slower than our actual growth in our business, right, which would improve the profitability of the business. So because this has happened, we've needed to start looking into all of these questions like, OK, so why is our bill so high? Where is that money going? The top-level cost like this doesn't actually show you a whole lot of information besides, hey, you're spending more money than you used to. But I do think it's interesting. There are a few interesting trends you can see here. So at this far left mark here at around November or December of 2017 is Black Friday. We have a very seasonal business. People do a lot of shopping starting between Thanksgiving and the end of the year. And so that spike there is their increase for 2017. We have an extremely large peak there, which is in about October. That was when we went and did load testing for Black Friday. We want to make sure that every year we can handle the load that we're going to see. We go and try to break our own systems. It turns out that that costs a little bit of money, so that's what that particular spike is for on that particular day. And then you can see Black Friday 2018. So you can see here for Bluecore, we tend to have this thing where our costs kind of go up, and then they go up a heck of a lot starting in November, and then they kind of stay at that level. And then they go up the next November, and then they kind of stay at that level. OK, great. So when we had these questions about cost, when we were smaller with about 10 software engineers, we would just go to the all-hands meeting and be like, hey, where did our cost increase come from? Last Thursday, something must have happened. Our data store cost is up. Our App Engine cost is up, whatever. Did somebody do something? And usually somebody there would be like, oh, yep, I think we turned on this new data feature. Let me go look in to see if that's what's causing the cost increase. We could go find it and solve the problem. Now that we're bigger, we have about 40 or so engineers, that doesn't actually work anymore. We have too many changes and too much complexity. So when we go and ask that question at the all-hands meeting, people are just like, I have no idea. We changed all sorts of things. Maybe one of our customers started using a feature in a new way that changed how our application runs. So we needed to go and do something to answer these questions. So cloud providers like Google provide you this nice advantage. There's really, really clear pricing. Go look at the price sheet to go see what something costs you. And they provide you this nice detailed bill at the every single day to tell you what you actually used and what things cost. Before I started at Bluecore, I came from an organization that owned its own servers, and so I kind of assumed that this would not be a problem in the cloud universe because you have this nice detailed bill. You want to know what something costs? Just look at your bill. It turns out that that is true for things that are separate. So for example, if you have fairly separable applications and you can have, say, a separate Google Cloud project for your team or for your feature, Google's built-in bill probably will give you the level of detail you need. It will tell you, hey, this team cost this much. Here's all the line items that this team actually used. And that may actually be sufficient. So if that works for you, that's great. But there are things that have to be shared. In our case, Bluecore is a software as a service application. So at least at some sort of high-level, logical level, we have one application that is used by all of our customers. And so we end up with some fairly big line items because of that. There's other good examples of this. One that I really like is like your data warehouse for your organization. The whole point of your data warehouse is to put all the data from your various different pieces into one database that then everyone in your organization can access to be able to learn the insights that they need to. By some definition, that has to be like a shared resource for your whole organization. So you're going to end up with some things that are shared and are going to be big line items on your bill that you may want to go get more detail about. So for Bluecore, what we really wanted is we really wanted to know what is our cost per team, per engineering team. We want to be able to have that accountability to say, hey, these 5 people on data science, your bill went up last month. Can you go investigate if that's expected or if there's a problem here? Or, hey, this email feature that just got turned on by this team, maybe it turns out that that's more expensive than we thought it was going to be. Maybe we need to optimize that. Right. We also wanted to know what our cost is per customer. So we are a software as a service application. It'd be really nice for us to look, hey, for some of our large customers, what does it cost us to actually provide the service to them? Do we have the right pricing model? And our finance team really wants to know projections. It turns out that they would like to know 6 months from now, what is our Google Cloud bill going to be? They're really unhappy when it's changing all the time, which it is. So they want to be able to have some model to look forward and say, great, what is it going to cost us in 6 months or the next year? What will it cost us if we sign this particularly large deal with this particular customer that has some specific needs? Can we negotiate or customize their contract? We need to know what it's going to cost us to serve them. So these things are somewhat organization specific. What Bluecore wants for the cost per team or our cost per customer is not what you are going to need. But the point is, these are fairly generic things. And you can sort of tweak these things to suit your organization. So as an overview, here's what we've done at Bluecore to break down our bill. Our step 1 is put everything into BigQuery. We already use BigQuery a heck of a lot, so that's a convenient place. You could put it into some other thing, but you need to put the data in one place so you can go and analyze it. We then combine Google's other data sources to get some additional levels of detail. And we'll talk about more specific details about which ones in a moment. And then step 3 is for things where we don't have enough detail from those existing Google data sources, we actually go and instrument the code to add that level of detail. The end result is you can make metrics that matter to your team. For Bluecore, it's that cost per customer or that cost per engineering team. But maybe for you, it's something else. You can do that by customizing the existing data that is available on Google Cloud. So as a quick example, sorry for this graph isn't super visible, but here's a quick example of what this actually looks like. This is our cost by type over the last 20 days. This is effectively our engineering team. So you can see this top line at the very top. This is the email cost. And you can see that in February 26, it was fairly high. And then it actually decreased because we deployed some sort of optimization. And then the next line here is events. So you can see for Bluecore, those are really the 2 big cost drivers. It's ingesting data onto our platform, which is events, and then sending emails, which is email. There's a bunch of these other teams and other line items at the bottom. From a cost optimization perspective, we can kind of ignore them because they're a small part of our bill. Here's a table that was created by somebody on our finance team using this data. Again, I can't actually show you any of the data, so this is just the column headers off of this table. This is showing the 25 lowest margin customers, and I really love this table. It shows the brand name, the monthly recurring revenue for last month, the total email and event cost, and then a computed margin, that is an email and event margin, that is how profitable or unprofitable it is, as well as a total email sends. The thing I love about this table is that our finance team created this without the engineering team doing anything. All we've done is we've provided this cost per customer with this email and event cost, and they combined it with the existing data about how much revenue we're getting per customer to produce this table. And this table has been super useful because we go and look at this and be like, hey, why is customer X costing us so much? That's really weird. And then inevitably when that happens, we go and look at it and it turns out there's some sort of configuration issue, or they're using some particular weird part of the product in a way that we didn't expect, and we can go and actually fix that and actually improve these problems. So this has been super, super helpful. And again, the part I love is the engineering team had nothing to do with this. The finance team actually created this themselves. So this is just an example of the kind of things that you can do once you actually instrument your bill to the level of detail that you need. All right, let's talk about how we can actually do this. First, let's talk about the existing cost management tools that Google provides. The first thing that you really should look at, or certainly I look at for any cost problem, is the Google Cloud billing reports. Bluecore has been a Google Cloud customer for long enough that this billing report did not used to exist. It does now exist. It's actually useful. If you haven't played with it, you should. It looks like the screenshot shown here on the right. It will show you your cost per project, per service, per line item or SKU, sliced over different time ranges. It lets you slice and dice this how you want. It's pretty useful. The part that is still unfortunate, though, is that there are things like this big blue bar here at the top that it can't provide you any more detail than the line item and project level. So why is this big blue bar so high? We're going to have to go do some work to figure that out. So the first step to figuring out why the heck this single line item is so large is to get the actual raw data. This is where the billing export comes in. This lets you get your detailed cost data exported directly to BigQuery. There's also a JSON export. I don't find that to be as useful. If there's one thing that you take away from this, you should go turn this feature on today. The reason is you can't go back in time and get the detailed billing data for data in the past. So if you are going to want to do cost analysis at some point in the next, say, year, and are going to want to look back at cost data from today, you need to go turn this on today. It probably won't cost you anything if you're not using BigQuery very much anyway. What it gives you is it gives you this sort of detailed data that's shown on the right. We're going to talk a little bit about it in a moment, about the actual Google Cloud bill. And there's some sort of schema for this. There's lots of documentation. OK, so what do you get when you actually, if you're actually working with this data, how should you actually work with it? A few tips that are useful to know. First thing is Google bills you. Google's official billing time is Pacific time days, so Mountain View Standard Time. You can convert the billing data into this time zone by using this BigQuery function here, timestamp trunk, take the usage start time, and convert it into this America Los Angeles time zone. Now you'll get days that are the same days that Google actually uses, which is useful when you want to compare this to your bill. Some of the data is delayed. It's a small percentage. It keeps decreasing. Last I looked before making this talk in February, it was something like 0.1%. Usually that data is delayed only by a day or two. Sometimes it's a little bit more, but not much. The point here is if you want to use this data, you're going to have to process chunks of time or reprocess it or delay your processing a little bit to make sure that you actually capture all of it. Tax and corrections show up much later. Tax shows up at the end of the month. If you have corrections or credits, they will show up way later. This can also screw up your analysis, so you may end up having to, again, reprocess this data multiple times to sort of get the correct view. And the other thing is this schema has human descriptions in it. It has a SKU.description and a project.description, or excuse me, a product.description. And these can change. The most recent change was Google changed this from calling it standard instance CPU and standard instance RAM to predefined instance CPU and RAM. This is totally fine if you're doing some ad hoc analysis and just looking at what was the cost last week. If you're trying to do some analysis over, say, a year, you're going to want to use the ID fields that Google provides. And now the problem is that those aren't human understandable. OK, what does this actually look like? So let's go and recreate this graph from the Google billing report. This is showing us the top SKUs by day this month. These are their top Google Cloud billing line items for the current month, broken down each day. So that was what the screenshot was that we showed before on the left-hand side. And on the right-hand side is the sort of BigQuery results that we want, which have the day, as well as then the actual line item here, like the front-end instance, data store, cloud data store read operations. What does this look like? Here's the example query. You don't have to understand it. I am going to walk through a couple of the parts that are somewhat important to give you a sense about what the actual raw Google billing data looks like. The first thing here is this day. This is this magic conversion to Google standard billing days. So timestamp trunk, the you should start time to this America Los Angeles time zone. Again, we want to actually go and compare to our actual Google Cloud bill. You're going to want to convert to that day if you want to be able to do that. This SKU description, this is this human readable description of that line item. And then we want to sum our cost, and this sort of magic expression here with this coalesce unnest thing is BigQuery magic to say, hey, take the credits that are attached to that line item and just sum them all up as well. So when you have credits like, say, the sustained usage discount in Compute Engine, there can be multiple credits attached to a single line item. We want to add all of those credits together to get the actual cost after the credits have been applied. We want to take the sum of days since the beginning of the month, so that's this timestamp trunk to the month and this partition time magic. Again, you don't have to understand this. And then we want to sum all these things together. The final result is going to look something like this. This is Bluecore's actual top line items for March 16th. Front-end instances, that's App Engine CPU. Google Cloud Data Store read operations. Back-end instances, that's also App Engine CPU. And then BigQuery flat rate annual. We're a big BigQuery user, so we pay for flat rate pricing. Great. So now we've just recreated what the billing report already gives us. So who cares? What's the point? Well, the point is we can now actually go and do additional analysis. And one of the things that you might want to do if you're a little bit crazy is actually go reproduce your exact invoice. Now this sounds a little silly, and I admit it is. It doesn't serve a whole lot of practical purpose, but it is very useful to be able to verify that whatever conversions or analysis you're doing is actually correct by matching your Google Cloud bill. If you want to do this craziness, Google provides you some tools to make it actually easy. First is provides this invoice.month field, which gives you a year and month string, which is exactly which invoice that particular record is going to end up on from Google's bill. So you can group by that. The second thing you're going to want to do is you need to round your cost and credits to 2 decimal places at the line item or the SKU level. So this is this round to 2 decimal points BigQuery expression there. Finally, the export data will show tax as one line item at the beginning of the next month, whereas if you look at your PDF bill, it will actually show you your tax on separate projects. So if you're comparing your PDF bill to your BigQuery results and really want it to add up, you're going to have to do a little bit of math. And if you do this, you actually get exactly to your bill, down to the exact penny, since December 2018. There's a document in Google's billing documentation which will show you some exact query examples. Again, is this actually that useful? It's useful for debugging things, but for the most part, if you don't do this, you're going to get within the nearest dollar anyway, so you don't necessarily have to do this unless you're like me and are kind of anal retentive and want to really make sure that you got it right. OK, so now what can we do with this? We have our raw billing data export into BigQuery. We now want to actually go and look at it and be able to produce some reports. I suggest that you use Data Studio. Again, it's built into Google Cloud. It's available for you for free. This is not a talk about Data Studio. I'm not going to tell you how to use it or show it to you. There's lots of other talks and resources about this. Again, the billing documentation itself provides some examples. But the point here is you can now create custom dashboards from this billing data. The reason this is useful is that there sometimes are things in the built-in Google billing tool that you may want to come back to multiple times. Like maybe you want to look at, here's the top cost for our production project combined with some cost for some of our top line items in a separate chart. You can create a dashboard in Data Studio just by pointing and clicking, save that as a link, share it with others, look at it every single day. So again, this is still the same data that's available in that billing report thing, but now you can customize it to look at stuff that is actually relevant to you and make that easier. I also just find Data Studio to be a useful tool to know about if you need to do some ad hoc visualization of BigQuery stuff or other data sources anyway, so it's useful to play with. OK, so this is basically the built-in Google Cloud billing tools. So now let's talk about what other data sources we might want to use to get more detail on this. So as a reminder, the point here is we have these big line items that are left. So for example, this big blue bar, what the heck is in this thing? We'd like to know more detail about where that's coming from. So there are other data sources about what you're using on Google Cloud that you can go and pull some of this from. As some examples, on App Engine, you have request logs that tell you every request that came into your application. For BigQuery, there are query logs that tell you about every query that got executed. For PubSub, there are stack driver metrics that tell you about the total bytes going into and out of your topics. For Kubernetes, storage, and compute, there are usage exports that will tell you various granularities of usage data about those things. And so we can go and combine these existing usage data things with our bill to find out what are in those big line items. So here's the plan. We're going to get the usage per day for one of these large line items that we want to understand in more detail. We're then going to combine that information with our official bill to get like a usage metric per dollar. And then we're going to produce an annotated bill that has that original data from Google, but broken out into these separate categories with this additional annotation. So the exact way you do this is going to depend a little bit on the resource that you want to break down. I'm going to talk through what we did for App Engine CPU, just because that is, for Google, this is the largest line item, or for us, for Bluecore, the largest line item that we have. The largest line item we have currently is App Engine front-end instances, which is CPU time on App Engine. We started 5 or 6 years ago as an App Engine application. It's still our biggest line item today. So how do we do this? App Engine has these request logs, and they look like this. You do not need to understand what is on this slide, but the point is there's a whole lot of data in this existing request log. And when we were looking at this, we noticed, hey, there's this line item here that says megacycles 29. What the heck is that? If you look at App Engine's documentation, it says something like, this is a suggestion of how much CPU is used by this request, but it's actually not very accurate. User be warned. So we wanted to know, OK, well, this says it may or may not be accurate. What can we do with it? So we went to Data Studio and produced a visualization of our total App Engine cost at the top. So this is the data from the Google Cloud billing export per day for this one line item. And then we went and summed this megacycles value out of the App Engine request logs over that same time period. And so what do you see when you see these two graphs? To me, that's pretty damn close. If you look at these two blobs here, you'll notice that they're not actually completely identical. There's a little bit of difference between these two things, but that's pretty close. So fine, maybe there's some error here. Maybe we're off by 1%. Maybe we're off by 5%. I'm not sure. But this seems like this is probably a useful data source for us. And in some experimentation that we've done by fixing some things, we've sort of verified that it is close. So now what do we do? Well, what we can do is sum the megacycles per day out of this App Engine log to get a total. And then we can compute what the cost per megacycle per day was. So 10,000 megacycles per dollar, something like this. Now we can actually compute the cost for each request, because each request has this megacycles value on it. And we can aggregate these URL paths by team and by customer to break down the annotation to get that level of detail that we want. There's going to be some stuff left over, and in our case, we just account this to unknown, because we're not going to get 100% of our coverage. And again, that's OK. That's one of the points here is we don't need this to be completely 100% accurate. We just need it to be like 90% accurate or 95% accurate. So what does this look like? Well, we end up, the next part I should point out is this is actually a relative cost. I don't actually know how much does a megacycle cost you. I don't know. Google doesn't tell us. It doesn't really make sense. But as a relative usage, a fraction of our usage of App Engine resources, it's a useful measure. And there's lots of other resources that sort of look like this as well, where you can say, well, this is a percentage of our cost for this day, and you can break it out that way. So what this looks like is this produces a table that has, say, each day. In this case, this is March 18th, a URL path or a URL prefix, and then a cost that it cost us for that particular URL prefix. So when we've gone and done this for Bluecore's bill, our App Engine CPU annotation gets us about 38% of our bill. We get that sort of team customer breakdown for 38% from that. We've also had to go and do this annotation for BigQuery queries. Like I said, that was our number 4 line item. So we do the sort of same thing by looking at the BigQuery query log. And we've also done this for Datastore storage by looking at this Datastore storage export data or usage data that we then export out of Datastore. When we do it for these 3 line items, we now have 49% of our bill that's left where we don't have this team and customer level of detail. So this isn't quite good enough. We got 51%, but we still need to know what's in some of this 49% before we know that we have an accurate enough estimate of our costs per team or per customer. So what can we do now? we're going to have to go instrument our code to get more detail about what's in that remaining bucket. So here's our plan. We're going to go and instrument our code. We're going to go and instrument our application in some way. We're going to emit that data. In our case, we emit it in logs, which then end up in BigQuery through the Stackdriver logging export. And then we're going to go aggregate this usage data by day, which will then look like what we did before with Google's own data sources. We're going to get some amount of usage for these additional line items on a daily basis, which we can then combine with the bill. So as an example, we did this for Datastore Gets and Puts. Like I said, we're an App Engine application. This is another large line item for us. It was the original sort of storage layer for App Engine. And the way you get charged for it is you get charged for every get you do and every put you do against this operation. So we want to count how many we have. So we have to go and wrap in our application all the get and put calls to count how many actually happened. We then log the counts at the end of each web request so that we can find out for that particular request how many did we actually do. And then we aggregate these in BigQuery using its like JSON extract function, which lets you pull fields out of JSON payloads. So the log that we emit looks something like this, where we have a counts section with the various counts we care about. In this case, this is Datastore Gets and Datastore Puts. And then we also attach this namespace thing. So this is from our application. We have a concept of a namespace, which basically maps to the customer. And so this is why we actually do this on a per request basis, is so that we can get back down to that level of granularity of a single customer. And then we can run BigQuery queries across our logs to basically sum these up and aggregate those together. So what does this look like? Well, now we can get a table that looks something like this, where we produce for a single day and a URL path or prefix how many gets and puts we did. These are absolute costs. Google tells us how much these actually cost, so now these just translate directly into dollars. So this is actually a little bit easier than the case where you only have a relative cost metric where you have sort of a fraction of usage. This one, we can just basically do the math and say, great, this URL prefix cost this much because of our, the price from Google. So here's an example. Here's what our actual detailed cost schema looks like. This is the sort of final output of all of these series of jobs that we've done. This may or may not be the ideal schema. It's worked for us. Hopefully you can use it for some inspiration. If you come up with a better one, please tell me. I'd love to know. So what does this look like? First here, the first most important field is this usage days specific. This matches Google's billing days. So this is this Mountain View Standard Time day from our bill. The next fields we pull out are the project, service, and SKU, or line item. These are the dimensions from the billing exports. These are fields that we group by from Google's original billing data. We then pull out the cost, usage amount, and credits. These are the metrics from Google's billing data, so we sum these out of Google's existing bill. The cost is the actual cost. Usage amount is some per service metric. So for Datastore, it'll be read operations. For Google Cloud Storage, it'll be gigabyte seconds or something like this. And then credits are the credit value. And the key part that we've done is we have two additional custom dimensions that we've added. So we, again, had this namespace, which for us is effectively a customer, and this cost category, which is basically a software component, which we can then map back to a particular team. And the point that we try to the constraint that we try to continue to make sure we meet here is that if we sum this table on some of these dimensions, that it adds up back to Google's bill. So we're adding these custom dimensions as additional detail again on the bill. So how do we actually produce this? So we get some original billing data. So as an example, we have a particular day, March 18th, a particular, it'll actually be a project and a SKU, but for simplicity, I'm just showing the SKU here, Datastore Gets, and we have some sort of cost for this. So it cost us $2,000 on that day. We then have instrumented our application to produce this usage data of showing for that day, some URL path did 2,400 gets, some URL path did 29,000 gets. And again, we can translate that back to cost. So we can combine these two things to produce this annotated bill, which now has 3 line items. So it has one Datastore Gets for, say, Team A. We have some mapping from these URL paths back to these cost categories or teams, and how much that actually cost. We have Datastore Gets for Team B. And then again, there's going to be some left over. We don't instrument every single application that we run. We just try to instrument the big users. And so there's some left over. In this case, say $363. And again, that's OK. We don't need to be perfect. We just need to get most of it in order to be able to make the right optimization decisions. So now that we've done this, We managed to cover 51% of our bill just by using Google's built-in other usage data sources. So we were able to get 51% of our bill down to this team and customer level without necessarily going instrumenting our application. And at Bluecore, we've then gone and instrumented a couple of data sources. So Datastore reads and writes is one example. There's a couple of others that we've done as well. That gets us to like another 24% of our total bill down to this cost category and customer level. There's going to be some left over. In our case, it's currently about 25%. And in our case, this percentage continues to grow. This remaining bucket continues to grow over time. And our approach has been, once it gets too large, we go and look at it and figure out what do we have to instrument next? What usage data can we import next? And the point, again, here is you don't have to be perfect about it. We just need to get it right enough and get enough of the data correct. And for us, this is sort of accurate enough. Great. So now let's talk a little bit about some of the lessons that we've learned through going and doing this. The first one is you really want to break costs down to teams, because that is what actually makes metrics actionable, is when you can get the responsibility down to a small enough pool of people. What is small enough? It's kind of going to depend on your organization. But in Bluecore's case, when it was 40 engineers and we said, hey, Datastore costs went up last week, that was too large. Everyone just sort of looked around and been like, it wasn't my problem. You need to get it down to a small enough group of people so that when you can say that to someone, they're like, oh, actually, we did something last week. Maybe we should look at this. As an example, here's a cost for one line item over 24 days. This starts at 0. It goes up to question mark number. And when I look at this, I say, maybe something happened there at the end. I don't know. There's a lot of variation. So this is what our bill looked like. I can't remember. I think this was in January. Here is that same line item if we look at just the responsibility for one team, for one cost category. Again, this starts at 0. This is the same 24 days. And you can now tell, holy crap, this went up by a factor of 2 for this particular team. Maybe we should go and look at this. Sure enough, we went to look at it. Here's that same team SKU over 46 days. We went and fixed the problem. The cost went back down to normal after this. So this is just an example of you need to get the metrics to the level of granularity that work for your organization so that you can go and look at something and say, hey, there's definitely something wrong here. It's definitely in this particular part of our product or our software. Let's go and fix the problem. This actually leads to another interesting part, is in the cloud, when you are using a lot of these automatic scaling features, performance bugs actually become cost bugs. And I think this is actually great. This is actually an improvement. In the old world, when you had a performance problem where your load went up, there was some sort of error, retrying, or customer load happened, your service just went down. So you knew about the problem right away, but it also meant that your application was broken and your service was broken. If you're using a lot of these auto-scaling things, your service is just going to continue to work. It just might cost you a heck of a lot. So you do need to keep an eye on these sorts of things to be able to find these problems before they cost you a lot of money. There are built-in Google features for this, by the way. There are billing alerts that you can set on various levels of granularity. There are all sorts of other things you can do. Finally, my big point is, again, make metrics that matter for your team. What has worked for Bluecore may or may not work for you and your team, but the data is there. You can go and do it. You can break it down to the level of granularity you want. It is possible to go and annotate this stuff to figure out where your usage is going. You just have to go do a little bit of work, and it's not actually that hard. To learn more today, there's a couple of other sessions still left. 10:20, there's automated cost optimizations on GCP. 1:15, there's aligning cloud costs with service delivery. You can go to the cost management showcase and talk to some of the Google PMs who are working on these sorts of things. And if you have questions about it, there's the Ask the Expert booth. And definitely go and look at the cost management documentation on Google Cloud. On cloud.google.com. It has details about all of this stuff that I talked about today, like how to set up and use the billing export. What does the schema actually mean?